My name is Jeff Lee. I'm a product officer at Fiilex. I'm also the head of product development and research for our lighting products. In order to maintain consistent color quality at all settings, all of our fixtures go through an extensive color calibration process. And so that essentially involves taking our fixture and then in color space, trying to hit about 192 different targets. And it's only after we can hit all of those 190 points do our fixtures pass the calibration process. So LEDs inherently are temperature sensitive. As they heat up due to ambient temperature or from them just generating energy, their color temperature shifts and their efficiency changes as well. And so the reason why we have to do so many calibrations on our fixtures is because we want to compensate for these temperature shifts. You not only have to calibrate your light at startup and at kind of operating temperature and then kind of extreme temperatures, you also have to calibrate and compensate for temperature changes as a function of the intensity. So as you turn your intensity up, the LEDs are generating more light, so they get hotter. Because of that, the temperature will start to shift, and therefore you need to compensate for that. Having more channels is essentially having more controls. So different colors or groups of different chips in an LED fixture are controlled by channels. So there's a channel that does one color, there's another channel that does another color. And in the case of Fiilex, we typically have at least 6, sometimes up to 12 different channels. And the reason we need so many channels is because we need so many different colors or groups of phosphors or LED chips. And what that does is it gives us a lot more control over the color space. Not everyone calibrates their LEDs. For those that do, they typically don't calibrate throughout the entire range. For instance, we need to make sure that our color temperature and hue and all the settings are good, even down to less than 1% intensity. The color calibration process essentially involves hitting different targets in color space. So typically, if you're looking at tungsten to daylight, you're looking at the black-body radiation curve and you're trying to hit things along that line. But if you start adding into hue, then you're moving sort of normal perpendicular to that curve. And so with the color calibration, we're essentially trying to hit targets around a kind of bounding box. And our fixture, once we can hit all those targets around the bounding box, we can essentially hit any color within that box as well. It's because of this calibration. So one, the chips that we use are really high grade. We manufacture themselves, we make our own chips. They are of the highest quality, and so they don't fatigue over time. Secondly, because of this calibration process, they sort of self-compensate for aging, which would happen if, for instance, if over time they become less efficient, and so they tend to heat up more, we would be able to compensate for that everywhere in that range. I'm Jeff Lee with Fiilex. Thanks for watching.